Good morning, everyone. We're the Group 6, and today we're going to explain about the Huntington-Hill. So what is the Huntington-Hill method? The Huntington-Hill method is also known as the method of equal proportions. This method is used in proportional representation elections like the one for the U.S. House of Representatives. Essentially, it helps determine how seats are allocated among states based on their populations. The Huntington-Hill method was developed by two mathematicians, Joseph A. Hill and Edward V. Huntington, in the early 20th century. It's considered a more equitable way to distribute seats than some of the methods used before it. So, how does it work? The process starts by giving each state one seat, and then additional seats are allocated based on a formula known as the Huntington-Hill index. This formula uses the geometric mean, a mathematical concept to decide which state should receive the next seat. The great thing about this method is that it helps prevent smaller states from being overshadowed by the larger ones, ensuring a more balanced and fair distribution of seats. So let's define these terms: the standard divisor, the coda, the geometric mean, the initial allocation, and the modified divisor or adjusted divisor. The first one is the standard divisor, by dividing the total population of all the states by the total number of representatives. The second one, the coda, divide each state's population by the divisor to determine how many representatives it should have. Record this answer to several decimal places. The third one, the geometric mean, cut off the decimal part of the coda to obtain the lower coda from computing square root of n plus 1. The fourth one, the initial allocation, larger than the geometric mean. Round up the coda. If the coda is smaller than the geometric mean, round down the coda. And the last one, the fifth one, the modified divisor or adjusted divisor. From step 4 was less than the total number of representatives, reduce the divisor and recalculate the coda and allocation. If the total from step 4 was larger than the total number of representatives, increase the divisor and recalculate the coda and allocation. Continue doing this until the total in step 4 is equal to the total number of representatives.
Okay, for the next, let's go to the description of the Huntington-Hill method. So it is used to fairly assign set based on population. It starts by giving a state one set, then calculate a priority value. So for each state, using its population and the number of sets it already has. So the state with the highest value gets the next set, and this process continues until all sets are filled. So this method is to ensure a fair and balanced distribution of sets. So this is the formula that we use. The priority value is equal to P over the square root of n times n plus 1. So where the P is the population of the set and the n is the number of sets that a state has.
So good day everyone. Today I will be discussing the steps of the Huntington-Hill method. So it is used for fair apportionment in legislative representation. It ensures that seats are distributed proportionally based on population. So I will explain each step. So for step 1 is solve for the standard divisor. So the standard divisor is calculated by dividing the total population by the total number of representatives or the seats available. For step 2 is determine the standard quota for each group by dividing its population by the standard divisor. So the standard quota for each state or group is determined by dividing its population by the standard divisor. So step 3 is round down each group's standard quota to the nearest whole number. So each state's standard quota is initially rounded down to the nearest whole number. For step 4 is compute for the geometric mean. So square root of n times n minus 1 of each group and compare it with the quota in each group. So round up the quota if the lower quota is greater than the geometric mean. and round down the quota if the lower quota is less than the geometric mean. So if the state's decimal quota is greater than the geometric mean, means round up to the next whole number. But if the state's decimal quota is less than the geometric mean, so round down to the nearest whole number. And for the last step, which is number 5, is if the total allocation from step 4 is not equal to the required number of representatives, recalculate the quota and allocation by choosing another modified divisor M and try it again. So after step 4, check if the total number of allocated seats matches the required total number of representatives. If the total number of seats does not match, adjust the quota by selecting a modified divisor and repeat the process.
So this is our first sample problem. A college offers tutoring in math, English, chemistry, and biology. The number of students enrolled in each subject is listed below. The college can only afford to hire 22 tutors. Using the Huntington-Hill method, determine the apportionment of the tutors. For the enrollment of math, English, chemistry, biology, it is listed here as 380, 240, 105, and 55, which sums up to 780 in total.
This is how to solve the sample problem using the Huntington-Hill method. We will apportion 22 tutors among 4 subjects based on student enrollment. So the step 1 is to find the standard divisor. First, we calculate the standard divisor by dividing the total number of students by the total number of tutors available. This divisor helps us fairly distribute the tutors among the 4 subjects. Step 2 is to compute the standard quota. Next, we calculate the standard quota for each subject by dividing its students' enrollment by the standard divisor. Now that we have the quotas, let's round them down to the nearest whole number. Step 3 is to round each quota. We round each quota down to the nearest whole number. So far, we have assigned 19 tutors, but we need 22 tutors, meaning we'll still have 3 more to assign. So the next step is to compute the geometric mean and assign extra tutors. So to decide which subjects get extra tutors, we use the geometric mean formula. Now we compare the standard quota with the geometric mean. If the quota is greater than the geometric mean, we round up and assign an extra tutor. After assigning the extra tutor, the total now adds up to 22, which is exactly what we need.
So hello everyone, today we're tackling an important topic on how to fairly distribute resources using the Huntington-Hill method. So imagine you're managing a tutoring program at a college where there are only 52 tutors available, but students are enrolled in 4 different subjects like math, English, chemistry, and biology. So how do we ensure each subjects get a fair number of tutors? Let's find out. So showing each subject has a different numbers of students, so we need a fair way to distribute tutors. So these are the step by step. So step 1, we need to find the standard divisor by dividing the total students by 22 tutors and compute each subject's quota by dividing each students by the divisor. That's step 2. And step 3, assign the whole numbers first, then distribute the remaining tutors using the geometric mean to ensure fairness. And the final allocation, once we finish this calculation, we have our final tutor distribution. And this method can be used in government, resource allocation, and more, and ensures fairness while considering a real-world constraint.
Now, we've reached the final part of our presentation. To sum all this up, let's be reminded that the Huntington-Hill method is a mathematical formula used to allocate seats in proportion to population size. It is a specialized method for apportioning that prioritizes minimizing the relative difference between the number of people per seat. And in general, the Huntington-Hill method provides a fair and balanced way to distribute seats, making it a reliable method in various fields, including politics and demographics.
So this is our references.